Hey guys, welcome back. We were discussing about the types of the covalent bonds in the last lecture, and we have just said this thing that there are three types of the covalent bonds. One of them is single covalent bond, double covalent bond, and the third is triple covalent bond. And how they are formed, this has been briefly discussed in the last lecture. Now we are going to implement that information. So, when we are talking about the covalent bonding structures, one should know this thing that in case of covalent bonding, basically, there are two or more than two or more than two similar or different non-metal atoms. This is very, very clear. Okay. And then when we are talking about the details, for example, number one structure which we are dealing right now is, let's suppose, hydrogen molecule. Point number one, how we know this thing that it will be formed through covalent bonding. Yes, it will be formed through covalent bonding because hydrogen is a non-metal, and a non-metal and a non-metal are combining with each other through covalent bonding. Okay, so let's see. Hydrogen has this information in the periodic table, which is just telling you that hydrogen has an atomic number of 1. So what will be the electronic configuration? It will be 1 as well. How many electrons should be in the outermost shell of hydrogen? There should be 2 electrons in the outermost shell of hydrogen. Remember this thing, this is the destination of all the elements, whether they are metals or non-metals of periodic table, that they want to achieve the electronic configuration of elements of group number 8. Elements of group number 8 are the basic destination. They all want to achieve that destination. Okay. So helium is the element of which electronic configuration hydrogen wants to achieve. Okay. So hydrogen has 1 electron in its outermost shell and it wants to have how many electrons? 2 electrons in its outermost shell. Okay. So let's see another hydrogen atom. Okay. It has also the same electronic configuration. We can say this thing that one hydrogen electrons are represented with the cross, whereas other hydrogen atoms are represented with the dot. Okay. Now, one hydrogen is with the cross and the other hydrogen is with the dot, and this is the structure. Okay, and this is the area. This is the central region. This is the area in which the electrons are placed by both of the partners. So, this is called as the sharing region. So, this diagram, we can call it as a sharing region diagram in which we have represented the sharing region very clearly. Now, both of the atoms are overlapping each other. You can see this thing. This is the structure. Okay, this is the overlapping structure. So here they're both of the hydrogen atoms and they are overlapping each other. Their atoms are overlapping each other. Their electronic shells are overlapping each other. We can see the cross and the dot in the center. Okay, afterwards there is a bonded diagram. We can see this thing that there is one pair of electron in the sharing region. One pair of electron in the sharing region will originate a single covalent bond. Two pair in the sharing region will originate a double covalent bond. Three pair in the sharing region will originate a triple covalent bond. So here, as there is one pair of electrons in the sharing region, so it is going to originate this single covalent bond. Okay, so this is the structure of hydrogen molecule. Let's discuss another. So right now, this is the number 2, and this is, for example, chlorine molecule. Okay, we know this thing that chlorine is written like this in the periodic table. Might be the periodic table you are looking into has 35.5 at the bottom and 17 at the top. But don't forget this thing at all, that in every periodic table there is a key and you should look into that key, that whether they are writing atomic number at the bottom or the mass number at the bottom. Okay, so it is not creating any difference, but you should look into the key provided in the periodic table. Okay, so let's see what is the atomic number of chlorine. It is 17, and we can see this thing. Let me reduce the size. Okay, we can see this thing that 17 is the electronic number, and what is the electronic configuration? It will be 287. Okay, So it is telling you that it has 7 electrons in its outermost shell. How many electrons should be there in the outermost shell? It should be 8 electrons to match the electronic configuration of group number 8. When I was teaching you ionic bonding, I have taught you there as well that if there is, for example, 1 electron in the outermost shell, they want to achieve the electronic configuration of having 2 electrons in the outermost shell to match their electronic configuration with helium. For example, let's discuss lithium. Lithium is a metal, so it cannot be part of covalent bonding. So when we were talking about lithium, in case of ionic bonding, lithium has an electronic configuration of 2, comma 1. Okay, so 1 was the electron in the outermost shell of lithium. Now 1 electron is not stabilized electronic configuration. So to match its electronic configuration with the elements of group number 8, lithium has lost that 1 electron, and its new electronic configuration was matching with helium in that case. Here, when we are talking about chlorine, it has 287 electrons, so it means that it has 7 electrons in its outermost shell. Now, its new electronic configuration will match with argon after sharing 1 electron. Okay. Now, we can look into the fact that in the previous video, we have discussed that sharing depends upon the demand and sharing depends upon equality basis as well. When we are looking into this, we can see that it has 7 electrons in its outermost shell. So how many electrons should be there? There should be total of 8 electrons, but there are 7 electrons. So it means that chlorine is going to share 1 electron to match its new electronic configuration with argon. Let's share the electrons of chlorine with each other. Okay, we have two chlorine atoms. One chlorine atom is represented, the electrons of one chlorine atom are represented with cross, whereas the other chlorine atom are represented with a dot. Okay, I'm writing another chlorine to clarify the case so that you may have a very clear idea that both of the chlorines have the same electronic configuration. Okay, so this is one and this is this. You can see this is the electrons of the outermost shell. Remember this thing that these are the electrons of the outermost shell which are participants only. All right, so inner shell electrons are never participant of any type of bonding. So whenever examiner is writing a question for chlorine, for example, he will say this thing, draw the molecule of chlorine, and your diagram should include the outermost shell electrons only. Okay. And in that case, you are not going to draw the electrons of sharing region only. Rather, you have to draw the electrons of complete outermost shell. You can see this thing that there are 7 electrons in the outermost shell of chlorine. Out of those 7 electrons, one is in the sharing region, remaining 6 are outermost shell electrons, but they are not part of the sharing region. We will discuss what will be the name of these electrons. But right now, let me draw the diagram first. You can see this is it. And I'm going to change the color so that you may have a very clear idea. Little bit, we should increase the okay, strength of the pen. Okay, so this is the sharing region. Okay, we can see that 6 electrons are there in the outermost shell of chlorine, which are not participant of the sharing region, and 6 electrons with the other as well. And there is a sharing region between the two, one electron from both of the partners. Okay, and this is this, and this is this as well. Okay, so this is chlorine, and this is the sharing region. All right, and we are going to draw the electrons on the electronic shell very clearly. You can see this thing that these are the electrons. Okay, so how many electronic pair are there in the sharing region? There is only one pair of electron in the sharing region, so it is going to originate what? This is this. Okay, single covalent bond between the two chlorine atoms. All right, now I'm changing the board to draw the structure of let's suppose iodine. Okay, so this is number 3 and this is iodine. Okay, iodine has an atomic number of 53 and has an atomic mass of 127. Oh my God, how we are going to draw these 53 electrons? No, we are not supposed to do anything. Just we should know this thing that as iodine is a part of group number 7, so it will have how many electrons in its outermost shell? 7 electrons. What about the remaining electronic configuration? We have no concern with that. Okay. So, for example, this is iodine, and I am saying that this is the structure of iodine, and it has how many electrons in its outermost shell? 7 electrons. That's it. We are not concerned with the remaining. Okay. And there is one electron in the sharing region. Let's draw it with the red color. All right, and this is this, and these are the electrons of the, I should write down I over there. Okay, this is I, and this is this, and this is this. Okay, and we can draw the electrons in the shading region. One is with the green color, and the other is with the green, and these are the electrons in the shading region. Let's say this thing that we are going to draw this iodine like this, and this is it, and this is it, and this is the electrons of iodine, and this is the shading region diagram, which I am drawing now. We can see this is the sharing region in the center, and these are the electrons here. And what is the next? As there is only one pair of electron in the sharing region, so what will be the diagram which will be called as a bonded diagram? We will say it will be like this. Okay, so this is the diagram. This is the sharing region diagram and overlapping diagram. I'm trying to explain it again. We can see this thing that iodine has a 53 atomic number. It is impossible for the students at your stage to draw the electronic configuration of 53 electrons, but I'm telling you that if examiner is asking about iodine or the astatine, astatine is the element which is below iodine even, and it has an atomic number greater than iodine even. So please look into the fact that as all the elements which are part of group number 7, they will have 7 electrons in their outermost shell, and they are making the diatomic molecules. What is the meaning of diatomic molecules? Means the atoms of group number 7 elements are combining in the ratio of 2 with each other, like 1 1. I mean to say, 2 fluorine atoms are combining with each other, 2 chlorine atoms are combining with each other to give you a diatomic molecule of chlorine, to give a diatomic molecule of iodine. So it is I2AT2. What is AT2? It is the astatine molecule. So all of them are sharing one electron with each other, as they have 7 electrons in their outermost shell. Out of the 7 electrons, 1 electron will be in the sharing region, and the remaining electrons will be written as it is. Okay, the outermost 6 electrons, the outermost shell 6 electrons will be part of the outermost shell, but they are not part of the sharing region. So same will be the diagram for fluorine, and same will be the diagram for iodine. Okay, so please be careful about that. Examiner is eager about iodine and astatine, and he is frequently asking the questions related to this. Okay, so this is the diagram for iodine molecule. Let's draw another, and this is number 4. All right, and we can say this thing that in number 4, we are drawing the structure of CH4. All right, now this is a compound, this is the molecular compound. Okay, so one more thing which I would like to inform you here, and that is called as lone pair of electrons. Okay, so what are lone pair of electrons? Those electrons which are part of the outermost shell but are not part of the sharing region are called as the lone pair of electrons. All right, so where are the lone pair of electrons here? This is the lone pair of electron. Okay, so these are the electrons which are part of the outermost shell, but they are not part of the sharing region. So they are called as the lone pair of electrons. What are the bonded pair of electrons? Those electrons which are part of the sharing region are called as the bonded electrons. So there is a difference between lone electrons and the bonded electrons. When examiner is asking about the outermost shell electrons, it means that he is asking about the bonded electrons, and he is asking about the lone electrons as well. You have to draw the electrons of complete outermost shell. All right, now I am taking you to the next, yes, methane structure. This is called methane. All right, not methane, it is called methane. And one more thing which I would like to inform you related to this, guys, this is the gas which is a major component of natural gas. What is natural gas? Natural gas is a part of our general use, and we are using it for heating and cooking purposes in our home. So this is a natural gas, and whenever examiner is writing natural gas, you should have an idea that he's talking about methane. Methane is one of the very important component of our environment. Source of an methane is cow dung, and this is produced by vegetable matter decay and organic matter decay. Sources of methane are part of your syllabus when I will teach you the topic of air and atmosphere, water, etc. Over there, we will discuss this thing that how methane is becoming part of our environment environment. I am just telling it to you by decay of vegetable matter or by decay of organic matter, cow dung, etc., etc. Now, methane is playing a very important role because it is a greenhouse gas. What are greenhouse gases? This will be part of our later discussion, but it is playing a very important role in our environment. All right, come back to the structure of methane. As it is a combination of two different type of elements, so it is a molecular compound. It is a covalently bonded structure, which is a compound. Okay, so this is carbon, for example. It has 6 atomic number and 12 is the mass number. When 6 is the atomic number, the electronic configuration will be 2 and 4. What about the hydrogen atoms? All of them has one electronic number, so electronic configuration will be 1. I am drawing all of them so that you people may have a very clear idea. I am drawing their, I'm writing their atomic number and their mass number as well. So it is just clarifying the situation that all of them has one electron and that one electron is part of their outermost shell. Okay, we can see this thing that carbon has 4 electrons in its outermost shell. How many electrons should be there in the outermost shell of carbon? There should be 8 electrons in the outermost shell of carbon. Okay, we have discuss this thing that all the elements should have 8 electrons in their outermost shell. So let's draw this. So carbon has this electrons with crosses, and we can see this thing that hydrogen electrons I am drawing with the dot, and there are 4 sharing regions, 4 separate sharing regions. So these are just telling you that there are 4 different bonds between same carbon and 4 different hydrogen atoms. All right. So this is the structure of methane. You can see that as in every sharing region, there is one pair of electron. So one pair of electron will originate a single covalent bond. So there will be 4 separate single covalent bonds between the same carbon atom and 4 hydrogen atoms. So this is the general structure of general covalently bonded structure of methane. All right, I can draw the structure, the sharing region diagram for methane as well, and this is this. You can see the diagram of methane. Here I will draw the carbon and hydrogen atoms. This is carbon, and there are how many hydrogen atoms? 4 hydrogen atoms. So you can see the dot and the cross diagram over there. Carbon electrons are with the cross, whereas hydrogen electrons are with the dot. So it is just telling you that carbon is in the center, whereas hydrogen atoms are around the carbon atom. All right. Thank you very much, guys. Take care of yourself. We are going to continue the lecture related to covalent bonding. All the best.